Hello children of the universe and welcome back to my channel, Makeup and Science. My name is Darky and this is where I like to play with makeup whilst I talk to you about science. I have a diploma in beauty therapy and services and a bachelor degree in science. This series is part of my science tutorial playlist about the solar system. This is the fourth video of the series. So in this series, I take inspiration from different celestial bodies on my makeup look, and I try to inspire some insight and wonder about the world around us. So without further ado, I bring to you Earth.
Stay a while and listen.
Gaia, Terra, the globe, the world. Earth is known by many different names, especially when you consider all the different languages humans speak. But where did the official name Earth come from? Earth has officially been known or named the planet Earth for at least 1,000 years. It is the only planet in our solar system that is not named after a Greek or Roman god. Its origins are found in the Old English and Germanic roots. The Anglo-Saxon origin Erda, which had a Germanic origin of Erde, evolved into the Old English word eartha or earthe, and like most languages, simply means soil or ground. And this here is the astronomical symbol of Earth. Earth is the third planet from the Sun. It is also the fifth largest planet in the solar system, but the largest of the planets on the inner solar system. So the inner planets are Mercury, Venus, Earth, and Mars, and separated from the other planets by the asteroid belt. They are known as terrestrial planets because they are made of rocks, heavy metals, and have a hard, solid surface. Beyond the asteroid belt are the outer planets, sometimes called Jovian planets or gas giants, as they are just that, giant planets of gas. They all have rings, and all of them have many moons. Alright, now back to Earth. Earth is the only planet that we know of that has free oxygen moving in its atmosphere, oceans of water on its surface, and of course, life. Earth is 150 million kilometers away from the Sun, which scientists have denoted as 1 astronomical unit, which makes it easier just to compare other celestial bodies in the sky for like distances. And it takes 8 minutes for sunlight to reach us on Earth. It takes Earth 365.25 days to make one full orbit around the Sun. That extra quarter of a day is made up for in leap years. So every 4 years we get an extra day on February the 29th. And just as we have leap years, we also have leap seconds. Because it usually only takes Earth 23.934 hours to make one rotation on its axis. So every few years, an extra second is added to a day, be it either June the 30th or December 31st. So you'd have 11:59 and then 59 seconds and then 59 seconds and then midnight. The next possible leap second event may be this year on June the 30th, 2021. The last time it happened was on December the 31st of 2016. Earth's axial tilt is 23.26 degrees, and it is responsible for our yearly seasons. So for example, when the Earth is in part of its orbit where the northern hemisphere is tilted towards the sun, you have summer in the northern hemisphere and winter in the southern hemisphere. Whereas in comparison, when the Earth is on the opposite side of the sun, the southern hemisphere will be tilted towards the sun and the northern hemisphere will be away, more pointed towards space. So you would have summer in the southern hemisphere and winter in the northern hemisphere. I gotta be honest, I don't know where this eye look is going, so have fun watching. With Earth sitting within the Goldilocks zone of our local star, we are able to have liquid water on the surface of our planet, which is really important because water has the greatest capacity for temperature regulation, thus, regulating our weather systems. The Earth has a diameter of 13,000 kilometers and is comprised of an inner core, an outer core, and the mantle, and the crust. And very recently discovered, as in discovered this year in 2021, is the innermost inner core, which scientists have theorized for many years, but this is the first time that they've found evidence of its existence, and they believe it's a liquid iron. So the inner core is solid iron and nickel, and they believe that the innermost core is liquid. So what this points towards is that there was 2 cooling events during the early years of Earth. So the inner core is, as I said, a solid sphere made of nickel and iron and about 2,500 kilometers wide. There, the temperatures reach just under 5,500 degrees Celsius. Surrounding the inner core is the outer core. It is 2,300 kilometers thick and excuse me. It is 2,300 kilometers thick and consists of iron and nickel fluids. And this is where Earth's magnetic field is generated. Above the outer core is the mantle, which is the thickest of the layers at 2,900 kilometers thick, comprised of molten rock and has the consistency of caramel. The top layer of Earth is the crust. On average, on land, it is 30 kilometers thick, and on the deepest ocean floors, it gets as thin as 5 kilometers thick. So it ranges between 0 to 100 kilometers thick. So in this image, you can see all the layers of the Earth, and then there is the 2 new categories that is sort of the transition zone between the mantle and the crust, which is called the lithosphere and the asthenosphere. The asthenosphere is viscous and has the consistency of toothpaste. It is the outermost layer of the liquid mantle. The lithosphere is solid and brittle. It is the transition between the lowest part of the crust and the most outer layer of the mantle. So the lithosphere is separated into different chunks, which is the tectonic plates, and they, either collide into like this, or they can go like that, or they go underneath like that. So the next layer of the Earth, above the Earth I should say, is the hydrosphere. The hydrosphere is all the water contained on and in the planet Earth. Approximately 1.4 billion cubic kilometers of water is contained on Earth, be it in liquid, gas, trapped underground, in the oceans, lakes, glaciers, and groundwater, or even vapor in the air. Earth is unique as it is the only planet that we know of with a hydrosphere. 71% of Earth's surface is covered in salt water as the oceans, and is an average temperature and is of an average temperature of 4 degrees Celsius. The oceans contain about 97% of all of Earth's water. The remaining 3% of Earth's water is freshwater, in which 3/4 of it is locked up in the form of ice at the polar extremes of the planet. The rest of fresh water is mostly underground or in soil and rocks. Less than 1% of fresh water is in rivers and lakes. Then there is the atmosphere. Nowhere else in the solar system is there an atmosphere like Earth's, which is loaded with free-flowing molecular oxygen, which is, really important for life on Earth, the other extremely unique thing about Earth. Earth is surrounded by a relatively thin atmosphere in relation to the size of the planet. It consists of a mixture of gases, a very minute amount of solid particles like dust and even some living organisms. So 78% of the atmosphere is nitrogen, 21% oxygen, and 1% argon, some other random gases, and an average of 1% water vapor, which obviously ranges greatly because, when it rains, it's at 100 or nearly 100% water saturation of the air. Now, carbon dioxide is only at 0.0395%, or 395 parts per million. And then methane is 1.8 parts per million, which, in the grand scheme of things, isn't a lot. But it's amazing how, such a small amount of greenhouse gases can make such a massive difference on climate effects, heating and cooling of the planet, and the health of all the living organisms on the ground. The atmosphere is split into 5 different layers. There is the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Now there is sort of a 6th one called the ionosphere, which actually spreads out over multiple of the layers, and it's always changing shape and size and everything, and this is where we get the auroras. So the auroras happen when solar winds interact with the ions in our atmosphere, and they are called the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere. The first layer of the atmosphere that sits on top of the surface is the troposphere. The troposphere is 7 to 29 kilometers thick and contains half of the Earth's atmosphere, as in the, molecules and gases and stuff like that. So the density, the volume, that you'll understand later. Air is warmer nearer to the ground, and it gets colder the higher you ascend into the sky. Nearly all of the solids and water vapor that's in the atmosphere resides in the troposphere. And that is why clouds are in the troposphere. Then there is the stratosphere. It is 20 kilometers thick and high in ozone, which is molecular oxygen, which is 3 oxygen atoms together, so O3 instead of O2, which is, what we breathe. So ozone is a pale blue gas with a pungent smell. Ozone heats up the atmosphere by absorbing the heat from the sun's rays, And it also reflects the harmful radiation emitted by the sun. We'd be cooked alive if it wasn't for our atmosphere, because all of UVC is reflected. If we would get hit by UVC, you'd pretty much just die. So, we get hit with UVA and UVB, so make sure you wear your sunscreen. As we travel up into the atmosphere, the air gets thinner and thinner and thinner until we leave Earth's atmosphere and end up in space. The third layer is the mesosphere, and the extreme sort of like outermost area of the mesosphere is called the mesopause, and it is the coldest part of the atmosphere, reaching as low as minus 90 degrees Celsius. So not much is known about this area of the atmosphere because balloons and aeroplanes travel much lower and do not, reach that area of the atmosphere. But then satellites and space shuttles travel much too high to be able to study that area. One of the things that scientists do know is that asteroids burn up in the atmosphere at this level. Then there is the thermosphere. The thermosphere ranges between 400 and 900 kilometers thick. And then the temperatures range between 500 degrees Celsius and 2000 degrees Celsius. Air density is extremely low in this layer and can often be thought of as outer space, as this is where space shuttles travel, satellites orbit the Earth, and the International Space Station is settled. Lastly, there is the exosphere. The exosphere is where Earth's atmosphere merges into outer space. It is 10,000 kilometers thick, and the temperature ranges between 0 degrees to 1,700 degrees Celsius. The exosphere is composed of very widely dispersed particles, so it's not dense at all. The particles are so spread out that they do not interact with each other at all. Now, our moon. Our moon's official name is the moon. And no, unfortunately, it is not lunar. And this is the astronomical symbol for the moon. Earth is unique in the sense that it is a planet with a single moon. So in our solar system, there's planets with no moons or with multiple moons, but Earth is the only one with one moon. The moon is responsible for making the Earth such a great home for us. It stabilizes Earth's wobble. So our seasons are pretty predictable. We know what's going to happen every year. It's going to get hot, it's going to get cold. Around the equator, you have your dry and wet seasons, and we can pretty well predict what's going to happen. Now, if we didn't have the moon and the Earth had a greater wobble, there would be greater variance in our weather system over the past, few thousand years. And we wouldn't be able to predict what was going to happen as easily, but also it would be more extreme. like our summers and winters would be all over the place. So our moon is different to other moons. So say, think of the moons that orbit around Jupiter or Saturn. Their moons developed when debris that are caught in the gravitational pull of the planet are orbiting around the planet and then eventually compress into one solid object and, become one satellite or their moon. With Earth, what they predict happened was, say, like a large asteroid slammed into Earth during the early years of development. And so the asteroid left, and the chunk that got smashed off of Earth, so all these debris and everything, started orbiting Earth. So you had like the main Earth, and then you had like Earth 2.0, which became our moon. Which is, really interesting when you think about it, like how much larger our Earth could have been and how different life on Earth would be if that collision never happened. And the moon is farther away than most people realize, at 384,400 kilometers, which would fit 30 Earths in between. Like 30 Earths. I didn't realize they were that far apart. Life on Earth. Earth is the only place in the entire universe where we have definitive evidence that life exists. The planet boasts of several million different species that inhabit quite a large range of different habitats. They include the deep ocean, the highest mountain, freezing cold temperatures, and the most hot boiling temperatures and acidic environments, and even reside within the clouds of our atmosphere. Researchers believe that there might be primitive life on other places in our own solar system. Candidates include Jupiter's moon Titan, which has rivers and lakes of liquid methane, and Saturn's moon Europa, which seems to be like a frozen bowl of water. The surface is solid ice, and they can see channels of flowing liquid water underneath, and they theorize that it might even be quite deep oceans. Now, one of the proposed missions is to send a satellite out to Europa and have it orbit the moon, and then to catch a sample of one of the watery jet streams that explode from the crust of the moon, and then test it for life. There are some theories of how life started or ended up on Earth. One of the theories is that the water that's on asteroids was deposited here through multiple collisions over billions of years. The other theory is an asteroid hit Mars and transported whatever life was on Mars onto Earth. Then the other theory is that life just sprang out of nothing, just straight out of the primordial soup that was early Earth. In 1953, a scientist called Stanley Miller performed an experiment to try and figure out how life could begin in the early days of Earth. He sent an electrical charge through a beaker that was holding a solution of methane, ammonia, hydrogen, and water. These are the basic of life and were present in the primordial soup of early Earth. The results produced was the creation of organic compounds, including amino acids, which are the literal building blocks of life. It is what DNA is composed of. Surprisingly, amino acids have been found on asteroids, meteorites, and interplanetary dust. So that's like the stuff that's between planets, and planets are very far apart. But where does, the jump from organic compounds then turn into life? And that's a question that scientists have not been able to answer as of yet. And with that, children of the universe, I would like to say thank you for sticking around and watching this video. I hope you enjoyed watching me do this sunset cloud inspired earthling look. I had no idea where I was going with it to begin with, and as per usual, all products are linked in the description box below, along with the scientific resources I use to do my research. And if you did enjoy watching this video, I'd greatly appreciate you hitting that like button and consider subscribing. I really enjoyed doing this look today. It is very artistic and fun. I also really love researching these scientific topics. So great to learn more and see where the gaps of my knowledge are. And obviously, there's so much to learn. There's no way that any of us could learn, like, not even half of the information that is out there. The amount of supercomputers needed to store all of humanity's known knowledge, and then there's so much that we just don't know. So it's just so much fun for me to have a reason to sort of delve into these topics and I guess bring it down to the everyday person's language that we can absorb and enjoy. So yeah, consider subscribing if you're wanting to learn more, and also watch me play with makeup. There's lots of other videos that I am constructing on different things that may not include science, but just talking about makeup. So yeah, otherwise, leave a comment down below as well. It really does help with the YouTube algorithm. And also I am looking forward to just hearing about what you guys think. Was it enjoyable to watch? Was it something new that you got to learn about today? And just to have a great conversation. I would really love to do that. So that is it from me. I hope you have a wonderful day, week, month, and year. And hopefully I'll be seeing you next time on Makeup and Science.